Hi, this is Chris from MDPI Encyclopedia, and today we are very delighted to welcome Dr. Zaman Sajid, a topical advisory panel member and guest editor at Chem Engineering, to talk to us about his research on process safety and AI in chemical engineering. Welcome, Dr. Sajid.
Thanks so much for having me.
You're welcome. Great to see you.
Same.
So Dr. Sajid, we have some very interesting questions we'd like to run past you. To begin, could you share a little about your academic and professional background and what led you to specialize in process safety and AI applications in chemical engineering?
Well, first of all, thank you very much again for having me for this platforms. And thank you for your question. I hold a PhD in process engineering from Memorial University of Newfoundland, Canada. It is a far eastern province of Canada. I do have MSc in chemical and process engineering from University of Strathclyde, Glasgow in UK. And I do have my Bachelor of Chemical Engineering as well. Very recently, last year, I completed my MBA as well from Anaheim University, California. So this is about a little bit about my educational background. My academic journey has always been grounded in a strong interest in improving three things in the industrial systems, which are safety, sustainability, and resilience. So these are the three main areas where I look to help research community. Over the past decade, I have developed a research and professional focus on process safety, particularly within the domain of risk assessment in oil and gas industries and chemical manufacturing. My transition into integrating artificial intelligence came very naturally as I saw there is a lots of potential of data-driven techniques and methods that can help to enhance the traditional risk assessment methodologies in chemical industries, and ultimately they will help the decision makers and the leadership as well. By combining the classical safety engineering principles into the dynamic risk modeling, my ultimate goal is to develop a proactive rather than reactive intelligence system that can detect and predict the hazards before some catastrophe can happen. And all of this will support the safer and more efficient operations in chemical industries.
Thank you so much. That's very interesting. And what motivated you to collaborate with Chem Engineering as a guest editor? And also, what do you feel distinguishes this journal in the field of chemical engineering research?
Well, my motivation to collaborate with Chem Engineering, especially as a guest editor, comes from the journal's forward-looking approach towards the safety and the use of the safe artificial intelligence. Chem Engineering of MDPI is a journal which provides a valuable platform that bridges fundamental research and practical applications across various chemical engineering domains, which include safety, sustainability, and very latest is digitalization. These are the areas which align completely with my expertise and my research interest as well. What distinguishes chem engineering is its openness to interdisciplinary approaches and emerging technologies. I have seen some journals which are very limited to a particular subject or discipline, but now we are moving into a modern era where we need some interdisciplinary research to answer very complex questions. This not only actively promotes the work that integrates artificial intelligence, system design, and risk-based methodologies. Being a guest editor, it allows me to contribute to shaping the research conversation, highlight the transformative work which we can do or borrow from other disciplines other than chemical engineering, of course, and support the global community of researchers which are driving responsible and impactful innovation in the field of the chemical engineering.
Thank you. That very much brings us to the present day. And your research focuses on AI-driven digital twins for process safety. Could you explain why this topic is particularly significant in modern chemical engineering?
Well, that's a very good question. Artificial intelligence-driven digital twins are transforming how we approach process safety in modern chemical engineering. Traditionally, safety assessments have relied on static models, periodic inspections, and reactive measures. So this was the goal of the traditional safety assessments. However, in these models, we are no longer sufficient. We don't have sufficient information where we can address the complexity of the modern systems, as I mentioned in my previous response. So in this scenario, the digital twins, which is the virtual replicas of physical processes, they help to enhance their system performance, predictive analysis, and scenario-based simulation if we integrate them with AI-enabled based time monitoring. This capability is crucial for earlier detections of abnormalities into the system. As I mentioned, the traditional system is based on static risk assessment, but having the digital twins enhanced with AI can help to have the dynamic risk assessment, which means we can practically see and look on the hazards before they can become catastrophic. So again, by integrating the process data, machine learning models, and safety logic, AI-driven digital twins can anticipate failures before they can occur. And it can enhance the safety, sustainability, and resilience of these systems. So if I summarize the response to your question, this approach shifts safety from a reactive approach to a proactive approach, which is essential for the future of the safe, smart, and sustainable chemical processing.
Moving from not just research, but into practical application, we see digital twins are increasingly adopted in industry. So, how does integrating AI enhance their capability in predicting and mitigating process hazards compared to traditional models?
Yeah, thank you for your question again. It's an interesting question. Well, in my views, integrating artificial intelligence into the twins, digital twins, significantly enhances their predictive and diagnostic capabilities, going far beyond that the traditional models can offer. Traditional process models are typically deterministic, which are based on predefined equations and assumptions. Well, I'm not saying they are not useful. Of course, they are useful, and we researcher communities have been using them for more than 2, 3 decades. However, these models often struggle to adapt in real time to changing scenarios and conditions. Let me give you an example here. Just like the sensor noise or the rare failure scenarios, these events can definitely disrupt our traditional models. Artificial intelligence, particularly machine learning and deep learning, allows digital twins to learn from historical and live data. This empowers the system to detect, understand the patterns, all abnormalities, and especially the precursor to the hazards that might be overlooked in conventional models. For example, artificial intelligence can continuously refine the fault detection thresholds, predict equipment degradation, and estimate the risk probabilities in dynamic operating environments. But all these things, which is the requirement of today's chemical industries, we can't get them from traditional models. So, in summarizing, I would say that AI integration enables adaptive response strategies by simulating the very old concept of what if scenarios under the various fault conditions in chemical industries. So, the digital twin can recommend the most effective mitigation steps before a critical event can occur. And this makes artificial intelligence powered digital twins a monitoring tool and an intelligent decision support for the risk management system.
In relation to the transition from traditional to AI based models, Could you discuss some of the key challenges in implementing AI-based digital twins for process safety, such as reliability, computational demands, and, of course, industry adoption barriers?
Well, yeah, that's a very good question. And there are very serious and the key challenges in all of this. Due to the limitation of the time, I will just stick them to a couple of them. Well, first of all, the data reliability is a major concern. We can develop the artificial intelligence models, but they need clean, complete, and accurate data. However, in our today's plant, the data is very noisy, which technically means it is not a data that we can directly use. We have to refine the data before it's using. Especially, this is true, especially for the systems which are older in today's modern industry. The second is the computational demand is high. Well, running a real-time simulations and prediction takes a lot of processing power, and connecting AI models with the existing control system also adds technical complexity. We try to reduce the risk in the industries. However, what we are doing is we introduce some bias which add the new risk into the system. And this is a big challenge these days, and we want to address this challenge. The third is trust is a significant issue. Many AI models would work like a black box, actually. And in safety critical settings, engineers need to understand how and why a system makes a recommendation. And finally, the adoption across the industry is very slow, to be honest. I particularly know some of the companies which are hesitant due to the lack of AI skills, and using the AI does need the people with a certain set skills for this. And again, the industries have the fear of the change management or concerns about the cost, particularly because we are working in an era where the dollar at every step of the industrial input output, we need to have that dollar measurement done. Of course, industry wants to make the profit, and as a researcher, we are here to support them. And for that purpose, we need strong collaboration between engineers, industries, data scientists, and management, and clearly demonstrate that AI adds value to the safety, reliability, and it adds the value to the profit of the companies.
You mentioned trust and proving the technology. So, are there any notable industrial case studies where AI-driven digital twins have substantially improved safety outcomes? And also, what lessons can be drawn from these applications?
Well, yes, we do have several industries. AI-driven digital twins have improved safety outcomes. For example, Shell and BP have used digital twins combined with artificial intelligence to monitor critical equipments in oil and gas sector. Well, these systems really have helped to detect early signs of system wear and tear, corrosion, or vibration issues before they become the safety concerns. Another example of the industries is the BASF. They have used artificial intelligence enhanced digital twins to simulate emergency shutdown scenarios, allowing faster and more informed operator responses. So when we look on these industries, the key lesson are very clear actually. The first is that integrating artificial intelligence can improve the safety management from reactive to proactive. It can help to reduce the downtime in the industry and improve the decision making. However, they also show that success depends on the data quality, strong cross-disciplinary teams, and building user trust in artificial intelligence is always important. So I would also acknowledge that being the researcher community, our aim is to make these techniques available to everyone so that researchers can do more research rather than limiting these to some industries.
Genetic algorithms and machine learning play a role in optimizing digital twins. How do you see the future convergence of AI, IoT, and high fidelity simulations shaping next generation safety systems?
Well, that's a very good question. What I believe the future of the safety systems will be shaped by the powerful combination of artificial intelligence, just like you mentioned, IoT, Internet of Things, and highly reliability simulations. When we talk about genetic algorithm and machine learning, they can help digital twins become smarter by finding the best system settings and preceding possible failures. When real-time data from IoT devices added, these digital twins can stay updated and reflect the actual plant conditions. They can help to have working in the real-time monitoring and ultimately high reliability simulations can help us understand the complex systems more accurately. Altogether, these tools will create safety systems that are faster, more productive, and more adaptive in nature, which means they will have the ability to spot the risk quite earlier and suggest the best actions in the real time. This means safer operations will be there. We will have fewer surprises at the chemical plants, which we always talk about. And it will help industry to have a stronger decision-making framework.
One final question. What advice would you give to early career researchers interested in working at the intersection of AI and process safety engineering?
Well, as I mentioned in my very first question, we are in a industrial era, where the collaboration is very important. So it's not that if I'm working on one field, I should not look on others. No, the success of our research community and industry is based on collaboration. So what my advice will be to earlier career researcher that who are interested in artificial intelligence and process safety management, they need to bring and build a strong foundation in both domains, artificial intelligence and process safety. And then they will be able to think in a way where they can have a solid understanding of the chemical process, and they will have the good understanding of AI techniques such as machine learning is an example, or data analytics and digital twin technology as well. Now, curiosity is something which I would like to advise all new researchers, young researchers, that they need to be open-minded because the field is evolving very quickly and it requires continuous learning. In the field of chemical engineering, particularly, I would talk, if we are not updating ourselves with the new information, with the new knowledge, which is keep generating every single time. Even if I'm talking to you, someone is publishing the papers or generating things, right? So we need to keep ourselves updated. I also recommend gaining hands-on experience by working on, again, interdisciplinary projects that involve real industrial data and safety challenges. Collaborate with your experts. This is very important. From the people from the different background, the young researchers, I suggest them to collaborate with them, learn about their field, share your experience. Because if you will share your experience, you will learn from their experience as well. So it will develop a collaborative environment where we all can work together. Finally, most important thing is the communication skills. I suggest early career researcher to consider the communication skills as the key element in your success. If I'm good in explaining, doing something, but I'm not good in explaining that thing, no one is going to get benefit from me. So explaining complex AI concepts is in simple terms to non-experts will help them to drive adoption and impact. I also teach in Texas A&M University, and I always tell my students that you need to explain me the technical thing in a way you can explain to your grandma. If my grandma is able to understand what I'm saying, this means I have the best communication skills I can ever have. So learn the technical skills in a way that you can explain to the non-expert in your area. And the important and last advice perhaps will be you need to be patient and persistent, because integrating artificial intelligence into process safety is challenging, but it offers huge potential to make industries safer and more efficient. And belonging from the research community, that's what should be our aim, and that's what we all work for.
Thank you. Well, that's terrific advice for today's scholars. Absolutely. And thank you so much for sharing your valuable insights with us today, Dr. Sajid. And it was an absolute pleasure speaking with you.
Thank you for having me. And I'm also very glad to have this opportunity. Thank you so much.